Welcome to Interface. Today we have an eminent professor, a biophysicist, a former professor in Indian Institute of Science, former Director General of CSIR, and we are very happy to have him over here. Sir, welcome to Interface. Sir, as you are a scientist of transdisciplinary research integrating structural biology with genomic, molecular biology and information science, can you please elaborate on the relevance of interdisciplinary research today?
See, the interdisciplinary research is the in thing. We build our science in silo, each of them, botany, zoology, we built in physics, chemistry, then we divided life science into botany, zoology, then we broke the material science and all. That's not the way the science will be future. We realize that solutions of tomorrow's problem needs integration. And genomics is a great field of science where all these interdisciplinary people brought in together to solve what you call the decipher the human genome code, to read the 3 billion letters that of ATGC that writes down the story of your life from the day of inception to the day you go to the grave. So how is this amazing information storage? To decipher that, we needed all disciplines of science coming. So I will say, therefore, future is interdisciplinary. If you are a biology student and you are weak in maths, then you are not going to be a great biologist. If you are a computer scientist and you don't start learning life science, then you are not going to do a big data analytics. So the future job, future opportunities is all multiple discipline of science that you learn. Silo experts role is over. Just imagine in our cricket team, we had 11 all-rounders, right? Nobody would have defeated us in the world. So we need multitasker. So it means we need a good fielder, a good batsman and a good bowler. Right? So we had few Kapil Devs. So we need multitask. That means people who understands multiple discipline of science, and this multiple discipline of science makes them expert in solving problems. The problems are complex.
Sir, although we talk about interdisciplinary research, how far we have succeeded? Still
our universities are still structured into departmental. There are some universities which has converged into it, and my Institute of Genomics and Integrative Biology is an institution itself which I founded, where we realized that the computer science, biology, chemistry, everything can converge. And there are faculties who have converged, students who come from all disciplines. So I think, I think it is difficult for students who are doing university studies for them to ignore this interdisciplinarity. And I don't think it is today important. 50 years back, I did PhD in molecular biophysics. So there is molecular, there is biology, there is physics. So it's old science. Science has been always the greatest discoveries have taken place in the interface of subjects and disciplines.
So you are hopeful that things will get together?
No. It's very simple. Either you are in interdisciplinary or you don't survive.
Yeah.
You have no market.
Yeah.
Today everything is market driven. Students who are going to listen to my talk, they are going to ask, how does it matter? Do I make more money? I said, yes. You can be a great data analytics person, big data analytics story, if you understand multiple subjects. Your market goes up if you learn multiple subjects.
What was the objective and achievements of Indian Genome Variation Consortium project, of which you are a man behind that?
Simple, in 90s the human genome was getting done, India didn't have money. So I was very interested, so I moved to Delhi to build an Institute of Genomics in 97. And we realized that when the human genome will be done, India will have a very important role to play, because India, according to the Tagore, we are a humanity where all parts of the world has come and met, Shakundal, Pathanmangal has come and converged. Now this we knew. So therefore, post-genomics knowledge discovery, this will be wonderful if we can have a basal understanding of the structure of genome of people of India, understand the disease genome variation, and India is the first country to actually map large number of variations in disease area and the drug response as a country-wise. We studied 55 populations across thousands of people. We brought dozens of institutions together. There were 24 PI. That's the very most difficult job, and on hundreds of students. And we published 2 papers, 150 plus authors. I think which is one of the largest co-authored paper published from India, and this actually gave the background genetic information on which then one can work on and develop diagnostics and all, and that's what is happening now. Lots of discoveries have taken place based on those. Hundreds of papers have been published based on various genetic diseases of the patient samples analysis. I can tell you 50 such companies have been formed who are looking at genetic testing, genomic services. So I will say there is a huge economic return of a program that started with only 8.07 crores of the Department of Biotechnology funding and subsequently about 25 crores from CSIR. So I will say it has given us hundreds of thousands of crore return, economic return.
That may be.
So the only difference is it was started much before anybody in the world thought of how functional genomics can be done as a variation of population polymorphism. So one has to have vision, and once that vision is there, you can make a difference.
That may be one of the first examples of a multi-institutional cooperation which has
Yes, it's one of the first example of such a scale operation done among groups of people who otherwise would have competed.
Yeah, each other.
Yes.
You are also well known for addressing the issues of unethical exploitation of genetic resources and projecting the rights of patients. Can you please speak on these particular aspects?
You see, when human genome sequence was going on and it was clear that the data will go into the public, I was very clear that to find solution to many of the genetic markers and eventually drugs or treatment or diagnosis or predictive medicine, or today what we call precision medicine, Indian gene pool will be very important. We are billion plus people, we have large families, multiple children, and although China has 1.3 billion people, but they have practiced one-child family. So complex genetic disorders needs multi-generation families with multiple siblings, which China cannot provide. So we are a great resource. Our patients, our population is a great resource for genetic discoveries. With realizing this, I raised the point that it is, genetic material was considered to be, genome was considered to be a common human heritage. You see, what does it mean, common human? Under Biodiversity Act, fauna, flora of nation and even the water up to 200 miles of the territorial water, the nation has a right. Yeah. But in 1996, UNESCO declared that human genome is a human heritage. It has nothing to do with your right. What does it mean? That means you can come to India, collect all the asthma patient samples and fly back to some other part of the world and do all the analysis. So India will become a resource supplier and not discoverer. So therefore, my argument was, how come human can be different? You are allowing the fish that can swim across the Atlantic, but you are saying 200 miles of fish from my land belongs to me. How come the people sitting on Kerala, they are not belongs to you, right? So this is an argument. So we had a long argument in the United Nations, we had argument in various forums, law and medicine, international meeting on human ethics. So then I was taken into the Human Rights High Commission Ethics Committee, where I argued, my argument was very simple, that if a patient of breast cancer has contributed to the discovery of diagnostic for breast cancer or even the medicine like Herceptin, but his sister gets breast cancer and she has to pay full.
Yeah.
So what about genetic dividend? Why not you give some genetic dividend for the people who have participated? So instead of giving individual, I said patient group should get back economic benefit. You can't make, when the patients have participated, never in the history of science where human became a subject of the study,
Okay.
where human is involved in the generation of knowledge. If I have put my blood sample, my health record is used, I have a right.
Yeah.
So I came up with the argument that ethical issues with respect to human genome has to be honored, the right of patients exist, and the reason it is, okay, DNA or your blood sample is not tradable, I agree, patentable. But what about associated information? The associated information that you have asthma, my brother has asthma, my sister don't have, this information is necessary to map the genome of the genes for asthma. So therefore, this associated information is copyright protectable, because the doctor writes down, he tells it, so it is his. So therefore, the DNA sample has no value without that information. Since the information is copyright protectable, you can actually link the two and say this DNA sample with this associated information is intellectual property protectable and it belongs to the nation state, and patient has a right on it. So that's how I became activist. Until I went to Delhi to build an institute, the argument is, okay, you protect these samples, but then so what? Will you make discoveries? So today, Institute of Genomics and Integrative Biology, for which I was the 10 years director, founder, has run for the next 8 years with the new directors and new people, so they're doing exceptionally good. And they have been able to exploit, they have been able to utilize large amount of genetic resource. And there are many other institutes who are under the Indian Genome Variation Project who participated. And we were a Lagan team. We didn't know how to play genomics. Nobody was trained in supercomputer and genomics. We learned ourselves. The way Lagan cricket match, all those farmers learned cricket.
Sir,
but we did not have that English lady to help us.
Yes. Sir, although we talk of all ill effects of population explosion, but I hear
yes,
a very
our
good
failure
point
of family planning is a genetic blessings to our genetic research.
Boon in disguise, we can say.
That's right.
Day,
Possibility.
Sir, can you explain to our viewers regarding open source drug discovery, because you are also
see, when I realized that many of the findings of this genomic data, where you can keep a low-cost drug down, or you can make a discoveries written for patent, and then we realized that those patent has no value when it is not commercially viable. You know, a patient not to take an expensive drug can stay with a cheap drug is no longer interesting for pharma. Then I realized the pharma is not actually interested in neglected disease. Human, to build a system level model is very tough. So I decided that why not we look at the tuberculosis, which killed 1,000 people per day. And just like Linux, when Linux started, there was a competition between Linux as open source and proprietary software. Even Apple also didn't like Linux, right? But today, 95% of the supercomputers are run by Linux. Red Hat, people have made money on Linux. It's not that open source you don't make money. Same way today, Apple would have been nowhere if after Android came, if Apple did not open up and says, you can develop apps on our platform. If Apple apps had to be all developed by Apple, Apple would not have been there. You know, iPhone 6 would have never come. So therefore, it is important to realize that the open source has a power. Number two, discovery has become expensive. And today, all the modern IT discoveries, you know, Twitter, Facebook, email, everything is all done by very young people. Whereas pharma is not done by young people. Now, young people cannot be brought in with too many lawyers around, legal, intellectual property, signature and all. So I said, why not we do open source? If we do open source drug discovery, lawyers don't come, young people can come, there's no confidentiality, anything we do, we make it public. It's a public, good for public, you know, you do open source. So that's how open source drug discovery project initiated, and that philosophy got initiated. And so it's not a project, it's a movement. Okay, and world has taken it over.
If some national institute are also working on this particular line, are they free to come into this?
Anybody. I am an outsider. I do not have any, national laboratory, or I was the chief mentor, but I can do anything. You can do anything. Anybody can participate.
But will they have some restrictions from the funding agencies?
Funding agency doesn't bother. You bring your own money, whatever resources, you can go back. I tell you, the most of the thing is not fund. Most of the thing is your brain power. You have to connect your brain power. And if we can connect the brain power, now there is, of course, Open Source Pharma Foundation has come, it's a globalized now, Tata Trust is supporting, so it's a movement, and it is no longer remained that, I got the idea and built on it, but it is taken over by the world.
So coming to another aspect regarding the crowdsource science, how this will help in the educational institutions of India?
You see, our education and teaching has become boring. Last 2 years, after I retired from CSIR, I was the education chairman of the Education Commission of Bengal to build a vision document for 2030-2020. It gave me opportunity for 2 years to spend significant amount of time into schools, colleges, madrasas, higher education, middle education, college, universities, everywhere. I realized that science and other things are very exciting, but you need laboratories, you need resources, and we have made it very boring. We do not need, we need to develop a complete new model. The reason I am saying why a new model is, you just see today in a state like Bengal, which is 90 million population, it will be similar. If there are 1 million children, 800,000 children in class 8, class 2 there is about 2 million children. There are Sarva Shiksha Abhijan and all this has helped. Now, if these children move on to the class 6, 7, 8, you will have another additional 4 million kids who will demand in the middle school, where you will get teachers. So, we have to come up with completely different. We have to make what you call learn yourself. So, we have to come up with innovative ideas where the students themselves will learn, come and put the data. And you have seen young children, young kids are very smart. You give them a new gadget, they work on it better than you and me.
Yeah, that's right.
Right?
Yeah.
So, therefore, we have to use their extraordinary unorganized skill, which is not taught by the teacher, that creativity to harness, and that crowdsourcing is the best. They get benefit of learning, you get benefit of job getting done.
Are you getting some government support also in this particular aspect?
See, I am no longer in government. When I was in government, things were all done. So, my job now is to find out how we can replace laboratory practicals, but still simultaneously do something that helps nation. Can we map agro productivity of the state? Can we use students to find those data? Can we upload those data on a website? Can we do GPS based analysis? So, I will say crowdsourcing will become very important when it comes to big data analytics, healthcare, health record. There are tuberculosis patients. Can we make sure they are compliant? Can our children in the school and colleges be given incentive to go and actually make sure that a patient is taking his medicine, right? Yeah. And that becomes what we call SUPW work, socially useful purpose, which becomes a chart drawn, parents go and buy from somewhere and put it up and you get a marks. Can we design all this using cell phone and socially relevant through crowdsourcing? You can use village children to just create a data of rainfall. What a learning it will be. To get a data on just study every pond, water body, measure the amount of water in water body, put up those data. So, even crowdsourcing can be done to educate them as well as to create national benefit.
What is the roadmap for TB research through the support of open science program?
See, open source, our always target was to make discovery, how to make discovery cheaper. And in computer work, that's the most challenging. Can I build a computer, whether I'll kill the bug in the computer, and whatever I will create, mimic or fight between the human and the bug and the medicine, we can simulate that in computer and achieve it in reality. So that's a dream. Dream is big. If solved, the world will waken up. So but the journey is interesting. It's very important to have a big dream, then dream thought into action. But dreaming is important.
Yeah, that is what our
So tell our students,
yeah,
do what you love and love what you do. Then education will be interesting. Otherwise, it's boring.
Let me also ask you one more question regarding the open drug discovery. How far the scientific community has accepted this particular?
Oh, it's now it has gone out of the hand of the India. It's a global phenomena. It has become exciting. Lots of people are writing book about it. Recently, Mark Stevenson from UK came and covered. He has written a book, a large chapter on open source drug discovery, where how the idea was generated, how it is done. I think it has become an international interest of activity, and that's why, as I said, there's an open source pharma has been formed, and therefore, I think it's an idea which, although generated in a poor country,
but now taken globally.
But I think it is taken globally.
Do you expect that price may reduce also for the drugs?
Oh, I have absolutely no doubt that this movement, you ask me, India got movement, India got independence, but that salt movement, the Dandi March salt movement was a moment, but it took many, many years after that to get. So, all I said, world has suddenly realized, if we have to follow the sustainable developmental goal, new SDG, which is the new 17 points, 3.3 of the sustainable developmental goal of the United Nations, to which all these countries of the world are signatory, where we have said we have to eradicate tuberculosis, malaria. And that can only be done if everybody puts their head. So I say, I was in a meeting in UNDP and there was a discussion on access delivery for all these drugs. How do you make Ghana, Tanzania, Indonesia access? So the argument I said that you can only make, if you can make the IT CEOs of IT companies talk to CEOs of pharma companies to say how Linux has helped them, open source, in creating business of supercomputer, then I think the pharma CEOs will understand that going open source for infectious and neglected disease is the right direction to go. And then if this is taken up, according to me, United Nations should direct that all this neglected disease, the sustainable development goal will be only met if the best mind of the world comes together and solves it. It is true for global warming, it is true for solar energy harvesting. So what is public good, global good? I think world need to be together and it should be open source.
Wherever we have great challenges.
Wherever the challenge is large,
and we have to
outcome of that challenge is great help for the humanity, and the sheer existence of humanity is in question, I believe open source is the way to go. And we have done the seeding, plant is grown. I believe before I die, I will see it propagate.
Yeah, hope something good will come out soon.
Absolutely, that's a hope. You live with hope.
Because for these particular aspects which you are mentioning, we need an immediate answer to all these things.
Oh yes, and action today.
Yeah.
Of course, Millennium Goal has given 2030, 15 years horizon, and in this 15-year horizon, sustainable development goals of the United Nations can be achieved.
We cannot expect small groups to.
No, I give you example. I give you a simple example. We realized that rickshaw pullers has nutritional deficiency, and Delhi city alone has 100,000 tricycle rickshaw pullers, and 20% of them get tuberculosis.
Yeah.
So we realizing, and each of the tuberculosis patient after 4 or 5 years, they cannot work anymore.
Yeah.
So their sons and brothers takes over. And this becomes patient, and each patient in a year, they transmit 5 people, they move children, they take a lot of school children around.
Okay.
So 100,000 TB cases gets generated, is by sheer estimate, by cycle rickshaw pulling.
Okay.
But it's a 1,000 crore business turnover. So we decided that how to replace this with electrical rickshaw. Today in the city of Delhi, 20,000-30,000 electrical rickshaws are running, and soon 27,000 run in UP, and it's all changed over hundreds of thousands. 500,000 is run all over the country, and when 8 million rickshaw gets replaced, I know we have reduced tuberculosis to a significant extent.
So not only the economic.
So it's not science alone, it's not the health science alone, it's not the medical science alone. You can actually do the other things to solve.
Yeah.
Right? Compliance can be done through crowdsourcing. You ask me crowdsourcing. I want the students, children, school children to do crowdsourcing to find tuberculosis reduction. So therefore, to me, when it comes to global good, tomorrow's knowledge is only those who can have, who has interdisciplinary knowledge, he who can develop projects through crowdsourcing, and he who can develop projects where open innovation is a part, which will be inclusive. I think that's the future.
If the message of this crowdsourcing can be brought to the concerned people, I think that is going to be a great.
Please remember, it is the people who will decide, not the university colleges. Students will learn, students will figure out. Today you can see social media is much more powerful, right?
Yeah.
So therefore, we have to respect. How do we use social media to teach, educate and change?
So at last, what is your message for the young scientists who are coming up?
There are not young scientists coming up. That's the whole problem, because science is no longer attractive. It's you know, many people say it is not poor, it is poorly paid, what do you do? So I say, if you do what you love and love what you do, you love traveling, meeting people, you love solving puzzles, science is a good profession. You know, I recently, somebody sent me a software on Facebook where you can put what are the countries you have visited. So I put it. When that came out, I said, looks so gorgeous, you know. Then somebody says, wow, you traveled on 42 countries, and many countries, several times. So I said, science is not bad at all. It's okay. It gives you opportunity to see the world, meet people, you have friends in every city of the world. You are never stuck. And you taste the food, best food of every part of the world, right? Culture, and all at others' cost. And that's the beauty of science. If you do not enjoy, communicating, if you do not enjoy knowing intricately, but you can be a scientist, then you are a mathematician.
Okay.
That's actually absolute science. So you can be a mathematician. But today it is, I will say, economic return is important, but you must do what you love and love what you do.
So I especially thank Professor Samir for spending his precious time with us and giving his ideas and what all he has conceptualized for the future of India and as well as the world. Thank you, sir.
Thank you.